Okay, good afternoon, everyone, and welcome to the final keynote session at Birmingham Tech Week 2020. And what a way to end the week. We're going to be talking about artificial intelligence, looking at the past, the present, and also the future. And most importantly, how AI is transforming our world. And of course, got the opportunity to finally, at the end of the week, join the conversation using the hashtags BTW 2020 and hashtag Birmingham Tech Week as well. And just kind of get out there and kind of share all your stories from across the week. We'd love to hear them. And of course, today I am joined by Bjoern, who is the UK public sector CTO at the wonderful Microsoft. And we were chatting before, and I was saying, as a young child, kind of, going into this new world of tech, looking up at Microsoft, and it's a real privilege to have Bjoern with us today. So welcome, Bjoern. And of course, the week wouldn't be possible without our partners that we're running the week in association with. So we've got Tech Nation, West Midlands Growth Company, and Department for International Trade. And of course, all the work they do across the West Midlands helps tech companies export their products and services, but more importantly, encourages inward investment to make sure that we've got the right economy in the area to grow our tech companies, innovate more, and create new and innovative digital solutions. And thank you to our sponsors, NatWest, who are our lead and headline sponsor, for all the work they do, really made this week possible, but also their entrepreneur accelerators up and down the country, and one in Birmingham, which helps so many entrepreneurs and tech leaders as well. And of course, big thank you to our sponsors, Copper, Culture Group, BGSS, Sidetrade, and BMet. And of course, our 2020 partners. I think I've kind of covered them all now. I've been giving them a shout, each one a shout out at different events. So I'm just going to say thank you to all of you at this point for your support during the week. And at this point, before I formally hand over to Bjoern, Bjoern wanted me to share a video with you. So what I'm going to do is just show you that video now, because it gives a really nice insight into what AI is all about, and specifically at Microsoft. So we're just going to play that now. And actually, just 1 second, I'm just going to do it again. Share computer sound. Yes, do it. And off we go.
Hi, I'm Brian Smith.
I'm Corbin Thompson.
And we work in the Cloud and AI division here at Microsoft on cognitive search. Cognitive search is an AI-first approach to content understanding. So no matter what shape your content's in, cognitive search gives you the ability to use all of our cognitive services to inspect and unlock all of that content and then search against it.
What we've found is that you can actually take AI in the cloud and have it do all that reading, have it do all the understanding, and then surface to you the most relevant bits of information. You could just compose the AI you want to express. What are the things that I want to extract from my documents? And it can go and extract all the information from your data source directly. It distributes all that compute in the cloud, and then it puts it and organizes that knowledge inside of an index so you can easily search it.
And while we're kind of going through this process, it just so happened that the government released all of their files from this JFK investigation, right? This is like 60 years of like typed and printed and handwritten and photographs and evidence and all these things.
We just ran all the content through, and right away you can see that the CIA, the FBI, and even Cuba was involved in all of this.
You've got a document. We needed to run like OCR on it, and we needed to run handwriting on it to find out where this thing was. So now we've got text. Then we go off and we take this text and we run all of the text through things that find entities, right? So now we've got an entity. Well, you can then link that back and you can say, here's what I understand about your content kind of in isolation. And then for anything that you want, now I can tell you everything that Bing knows about this relative to the whole world. And you can express all of that in basically 3 skills, which is really powerful.
Not only can you see that information, but it organizes it in a way that you can actually navigate the data very quickly. So what we found is we could express this as a graph, and then you can just see how each of these topics that are discussed in these documents are related to each other. And so whether you're trying to figure out who assassinated a president, or if you're just managing thousands of contracts or engineering plans, we found customers in all these industries users derive value from the content that they have. You can take AI, compose it together, and unlock all the value, that latent value that you have in your content, and start putting it to good use. And all the cognitive capabilities we showed are built into Azure Search.
So you can get started today in just a few clicks. You can go through and you can add the cognitive capabilities to your content and get it into Search Index so you can start asking these questions on your data.
And we've published the code that we have, so you can just go today, put your content into the cloud, and have the same experience that we just created in just a few minutes.
But no matter what you choose to do, I think you'll be surprised to find how easy it is to take all of Microsoft's AI capabilities and use them together in cognitive search.
So while Bjoern gets his slides up, I remember when Bjoern showed us that video, and we were just kind of flabbergasted really at kind of the capability, but also around such a kind of prominent story. And I can see Jay Ward there kind of says wow, and I think kind of at that point, Bjoern, on that note, I am going to, yes, we will share the link to the video, absolutely, but I'm going to hand over to Bjoern, who can kind of kick us off.
That's great. So thanks very much, Yanis, for the brilliant introduction, and I'm really excited to be here and do this session. So as you appreciate, AI or artificial intelligence is really important to me, and I think what we've just seen from the video, the amazing capabilities out there. So if you are as fascinated as I am about the JFK example, in actual fact, this is probably 3 years old now. We will come back to that later in my session. So first of all, I want to start the session really off with a statement the Google CEO made back in January 2018. So artificial intelligence will be more transformative to humanity than electricity. That's a very bold statement. I've put, to give a little bit more context here, the diagram that Gartner created to demonstrate their prediction of the business value, so the business value forecast by AI type. I know it's probably a bit smaller, but you can of course find that information on the Gartner website. But you can see how much value AI obviously has for businesses. And this is just something I want to take us through the whole session here. If you've got questions, please post them and ask them. Obviously, Yanis shared the information earlier. So to get us really started now, let's have a quick and brief tour through the history of AI. So you can see we started quite early on with the early phases of technology, and back in 1642. I don't want to go through the whole comments there. Again, this is something you find online, but I want to really put the finger on the year 1955 when an event took place very similar to what we have here now with the Birmingham Tech Week. And that was when the term artificial intelligence and AI was very first mentioned. So if you consider this, AI is quite a young subject matter. So as we go through, and obviously the Industrial Revolution took place, and computers were starting to be used more and more, and the compute power increased more and more. We reach a point when you've probably seen this, that large, massive computers were used to challenge chess players, and there were big competitions, and then computers starting winning chess games, which in itself is quite interesting. A bit more recent, the tech companies starting to use the big supercomputers to challenge Go players. And I want to give you a little bit of an insight into the game of Go. So Go is a game that has a grid, and you have probably over 350, 360 crossings on this grid. And you need to put your little chips on the grid to basically see who can put the most chips there and conquer the most area on the Go board. So if you are familiar with chess, you know chess only has 64 fields and Go, as I said, has over 360. So immediately you can tell it's a different dimension. To put that more into perspective, in chess, you probably have an average number of moves of 37. In Go, you have between 150 to 200. So to work out the number of possible moves that you can have is quite substantial. So the number, let me just move my thing so I get the right number here. So you probably have 320 billion possible combinations of moves when you play Go. So for a computer to beat a very experienced Go player is quite a challenge. One of the most famous Go players in 2016 was a player called Lee, and you see that picture here. Lee was beaten in 2016 by the supercomputer called AlphaGo, and you appreciate that supercomputer was built for that purpose. And the player was so taken back, and with the background of the game Go I just gave you, he decided to retire. He announced his retirement back in 2019 because he said, there's no point in playing this anymore because I can't be on top of the game because computers have taken over now and are so powerful. So that's quite something to step away from something that is your profession and your absolute skill. So as you can see, computers and artificial intelligence, the compute capabilities, compute power is so enormous today. And throughout the rest of the session, I want to give you some more insight into the various aspects where AI can be used. But on the next slide, I want to just give you a little bit of an insight, because the terminology that's always in use is artificial intelligence, machine learning, and also deep learning. We haven't talked about this yet. So I want to put those three terminologies a bit into a context, and a picture always says more than 1,000 words. So if you take it very simplistically, artificial intelligence is everything we talk about, and machine learning is, so to speak, a subset of artificial intelligence, and deep learning is again a very narrow field within the machine learning capabilities. So this is really to help you frame this whole area, which is quite a complex topic, but artificial intelligence basically is everything that we talk about to mimic human intelligence using logic and certain rules and decision trees. And then machine learning are the statistical techniques and, as it says here, enable machines to improve the tasks with experience. So the machine is actually learning from what it is doing. And deep learning then, once again, as I said, is a subset here to describe that even more precise and have this multi-layered and neural networks to leverage. And again, I have a slide later on to explain this multi-layered aspect and how you can leverage that. So, so much to talk about. I want to show you some practical examples. If you're not very familiar with where really AI is already has a foothold in and involved in, I can assure you AI is very much present in every industry and every sector you can look at, but of course also in your consumer market, in your consumer products. So just to call out a few, by no means this is not a finite list here. I'm sure if you are immersed in these or other sectors, you have probably seen more telling examples for yourself, but I just want to call out a few to really show the relevance, and that is indeed related to AI. So the first one here, using bot technology for insurance quotes. Most of you probably have contacted an insurance company, and when you go to their website, you see a little chat popping up at the bottom, can I help you? And you start asking questions, and some of them even take you through an insurance quote altogether just with this little chat bot. So that is all possible. And you will be surprised, these chat conversations, even though it says there's a name and who is talking to you, I can assure you these are all just bots. There's no person behind the chat. Only if the chat comes to a certain decision point to say, oh, now I need to speak to somebody, then it will hand it over to a real person. But all of these bots, there's no person behind them. Hopefully I haven't crashed anybody's beliefs, but that's the reality. So the next topic here for banking. So banking, the large banks, they all use already technologies to detect fraudulent transactions through pattern recognition. That sounds really difficult, but sometimes you get contacted by your bank to say, oh, was that really you who just went on this website and bought something, or is it you who are now in the foreign country to make a transaction? The reason why they're contacting you, they look at your entire history of your transactions, and they will see with certain patterns if there's something that is abnormal behavior, and the machine learning takes over there. There's not a person looking through each line. So the machine learning, that's a great example where we have a real-time interaction. So as soon as the transaction takes place, machine learning looks at it and thinks, oh, he never shops on the internet at 2 o'clock in the morning and never shops from a website which is outside the UK. Then that's a good example where machine learning can then transact and react for you and block the account, block the transaction, whatever is applicable for the bank there. Local government, and as you've seen, for those of you who don't know me, I'm a public sector CTO in Microsoft. Local government, of course, is very close to my heart. There are so many examples for AI usage or machine learning usage, and I really struggle to choose which one to pick. And I thought I'd pick one that probably most people are quite familiar with, which is Potholes. And the government has the technology, and some councils already do this, to, for example, have a camera on the bottom front of a bin lorry, for example. They drive around the streets as obviously the bin collections take place. And what you then can do is you can analyze the video footage and detect from the video footage where there is a pothole. And then they can analyze how many potholes are on a certain stretch of road, which stretch is useful to be re-tarmacked. And obviously this way you save people not having to do this assessment driving around separately. So we leverage what the bin lorries are doing and get the information and the insight that way. And as you can see here, this is a completely different scenario, because here we talk about object detection and analysis. We could take that a step further. The pothole could also be analyzed in terms of size and depth and diameter to say, okay, and I need roughly, I don't know, 5 liters of tarmac to refill this pothole. So again, be very efficient with the resources that you're using there. For health, I wanted to pick a couple of examples, but again, there are loads more. So for cancer diagnosis, obviously you use, for example, X-ray images. And if there's a tumor in the body, then normally a doctor or physician would look at the image, and from their experience and certain patterns, the way the material looks like, you can tell that, yeah, that is probably cancerous. All that great knowledge has been fed into machine learning models. So now we can actually, with even greater accuracy, just feed the current patient's X-ray imagery into the system, and the machine learning can analyze the picture automatically and call out if there is a very accurately detected cancerous area or not. And through the degree of accuracy, we're not taking the human skill out of the equation, but we just want to help increase the accuracy. And for something that's probably not as accurate, we still have the human to cast their eye over as well. Another example, and this is an example I want to bring in here because here we actually use deep learning. So with all these imagery that we have and also the radiology and radiology diagnosis combined, we're combining unstructured medical data, so radiology images, blood tests, which is obviously numbers, EKGs, which are graphs of a patient, and genomics, and even the patient's medical history, which is just obviously transactional text. All of this together, as I say here, it's a combination of structured and unstructured data. All of this together with deep learning can form a picture of a person's health, and that can also be used to diagnose. So health I find really fascinating. There are lots more examples. At the moment, Microsoft research in Cambridgeshire is analyzing people's, not just people's DNA, but also people's blood, because for each infection that you have, the body produces antibodies. So the total amount of different types of antibodies in a person's human blood gives you also a snapshot of the medical history. And again, fascinating topics. So these are just a few examples for the use of AI, and I think, yeah, it's quite amazing. Just wanting to bring Yanis into the conversation. Yanis, have we got interesting chatter going on? Any questions already?
Yeah, there's one question here, and it's kind of how will AI play a role in, I guess, the smart city and the future of mobility?
Okay, great question, and absolutely. So because I didn't cover this kind of aspect in here, so for smart cities, we have lots of areas where we can use AI and machine learning. So we can understand where hotspots of traffic are. That could also either lead to revised planning, so it can aid the planning departments in a council. It could be used to maybe improve the traffic light system to say, do we need shorter or longer intervals to reduce the emissions? Smart cities could be used to understand where do we need more or less parking. So again, we don't want just everywhere car parks. So there are different areas, but yeah, smart cities, we can then even take that into the housing market, either through social housing or just in general, understand how well insulated houses are. With drone technology, you can take aerial images, which are thermal images, to just understand how well insulated houses, entire streets are, older housing stock, to really improve the way, because obviously more heating because of worse insulation also increases CO2 emissions. So again, all helps there really. Lots of examples. Intelligent street lighting. If a street is not frequented, we probably only need every other street lamp turned on, that kind of thing. So really great examples for city and yeah, IoT in the city.
I've got a question here from Jalward. I think I know how you're going to answer this, but it's interesting nonetheless. How would you compare the AI tool sets and platforms from Google, IBM, and Intel with those from Microsoft?
I want to answer this in a more inclusive way. The Microsoft tool set is really there to give you the platform, but offerings from IBM or even others, most of them have more the technology and the sensors, and that's not our market. So you really build a cohesive ecosystem with all the different players together, and you can leverage whoever has the best technology, so best of breed. And IoT really allows you to do that. So especially the market of sensors and having the sensors at the edge, which means you don't have to always send all the traffic back to a data center or to the cloud. Lots of processing can take very close to where the sensors are as well. So really look at it from having an ecosystem and just use what the best tool for the job. That's how I would describe it.
And I think kind of one more question kind of that's related, I guess, to kind of mobility in smart cities is we've heard a lot about 5G today. What role does 5G play in, I suppose, kind of allowing AI to then distribute data across the network?
Yes, absolutely. So 5G is phenomenal because it allows a lot more data to be transmitted without having a cabled network, or even Wi-Fi isn't that strong. You need far more repeaters or transmission equipment there. But 5G just allows you to go in even the most remote corners, especially here for local government. Some counties are so rural, and with 5G you are able to reach the furthest corner. And if you then take the example I gave about medicine, the amount of data, the X-ray imagery and so on, you could, if the technology allows, I'm just making this up, but you could take an X-ray image right at the scene of an accident, if that's possible, and then with 5G, X-ray imagery is quite big in terms of data. You could still then with 5G send it back to the hospital to allow the high valued processing there, or wherever it takes place. So 5G is phenomenal because you've got obviously the broad coverage and the high data throughput. So it really will aid the exploration of AI and machine learning even more.
And there's a question as well on bias in AI, but of course I know that you're going to come on to that in a minute, so I'm going to let you carry on and we'll pick up questions in the end, but they are coming through thick and fast now. So yeah, to see the rest of your presentation and we'll pick up Q&A at the end.
Great, okay. So, and bias is exactly the next topic I want to talk about. So as I put the summary here, how to account for unconscious bias and the importance of diverse teams and how AI can improve accessibility. If we understand that machine learning is obviously we or humans provide a data set of information to train a computer model, which then is used for real-time data to look how does that fit in with the data and the computer model that I provide to then give an answer. This computer model, this pre-loaded and pre-trained data is unfortunately today usually very biased. And in the last week or so, you've probably seen lots of articles how Microsoft is trying to close that gap and overcome the bias in certain areas. Let me explain why we have this bias, and I have a couple of examples here. So especially when it comes to disability, bias and AI is really those three things together. So two examples here of current state-of-the-art AI systems that are biased and do not work properly or even discriminate against people with disability. That's the PWD bit. We have already automated speech recognition tools, and everybody has them at home. Siri, Alexa, Cortana, we all have those. And the speech recognition tools that can capture videos for people who are deaf or hard of hearing. And with that, we have obviously language prediction algorithms that can augment the communication for people with speech or cognitive disabilities. But what those pre-trained models struggling with is, if somebody is hard of hearing, their speech isn't as clear as somebody who is not hard of hearing. Or we have people who speak with a strong dialect. The problem with all the speech recognition systems is they are not trained for a not clear speech. So therefore, immediately, people are disadvantaged because it's not working properly. But the reason it's not working properly is because the machine learned models that have trained the speech haven't considered those different reasons why the speech might not be as clear as necessary. Similar topic is when we look at computer vision. So computer vision algorithms typically learn from large image data sets and pictures downloaded from the internet. Most of those are taken by sighted people and reflect the photographer's interest with items that are centered and are in focus. Somebody with a vision impairment, or somebody, for example, who is in a wheelchair, has a different point of view, or with a vision impairment can't put a picture in focus. Or somebody who is blind might have a different reason for wanting to get information out of a picture. If I take the view that I currently have of Yanis, the current computer vision algorithm would say, I see a man with dark hair and a beard and a gray jumper. If somebody with a vision impairment would want to take a selfie to understand how is my appearance, they might not be interested that it is a gray jumper, or somebody who is colorblind, because that doesn't mean anything to them. To them, it might be more relevant, does the jumper have a stain on it? Rihanna, you haven't got a stain on your jumper, I'm just saying. But
at least I don't think I have, Bjorn.
Yeah. So this is showing different aspects, what is relevant to the relevant audience. And that's why not just I say this, but we recognize current data sets are biased, and obviously that's not helping people with certain disabilities or for different reasons. So Microsoft is making a great effort to close, we call this the data desert, because there's obviously a big chunk of data missing, and we're trying to close this. We can also later share some links around this, but this is a very current topic, and I think very important that we all make an effort to address this. Good. So if we look again at the more technical and analytical side, let's now talk about why predictive analytics should be used for decision making and how this can lead to operational efficiencies. Predictive analytics obviously is part of artificial intelligence, because you've got a data model, and normally you would say, oh, I'm making a trend and I can see where the trend is going. And in analytics, we call this predictive analytics. So where are we heading? And with machine learning, if we can beat a Go player, you can trust that with the right amount of data, you can also base factual decision making on a data set, and that's what we call predictive analytics. So again, I've brought a diagram in here from Gartner. I just tend to use them because they are well recognized for looking at information in a really neutral way and in a really constructive way. So to summarize this slightly differently, predictive analytics is a method aimed at making predictions about future outcomes based on historical data. That's what I call the data set, and analytics techniques such as statistical modeling and machine learning. That's why we are talking about this in this context. Organizations use predictive analytics to leverage current and historic data to detect trends and forecast events and conditions that should occur at a specific time based on the supplied parameters, or let machine learning detect trends and deliver actionable insights. So typically when an organization starts to leverage more analytics and more data, typically you start with only your historic data. And with historic data, the problem is it's very reactive. The events have passed, the data has been collated, but you can't really engage in and influence an outcome based on historic data. That's why we are introducing machine learning into the analytics world to help leveraging the same historic data, but then predict, if we do, I don't know, weather is probably not a good scenario because it's highly complex. But if you look at the weather reporting, I think over the last 2 years, you will see it has become more and more accurate as well. But just in any field today, if you are working in a sales environment, you remember I talked earlier about the insurance company with the bots. You can learn from how somebody's interacting with the bot, how long they stay on the website, how likely they are to transact with you. So machine learning is really important here. Predictive analytics also has a great use case when it comes to engineering, because you can predict, for example, the fault of an elevator based on just measuring the telemetry and all the different components. If you think Transport for London or other transport networks, you can use all the telemetry that you have to predict how many passengers there will be on any given tube. You can predict the reliability of your trains, and also you can again predict when do I need to schedule a maintenance. Even in today's world, you still have, think of your cars. Oh yeah, you need to take your car every year or every 3 years to get it checked over. But actually, wouldn't it be much nicer and more convenient for us consumers to say, actually, I only need to go when the car detects a fault? So more modern cars, I think Tesla already offers this. They warn you and say there's a fault coming and you need to take it to the garage. But these are the areas where predictive analytics and machine learning can really help.
Bjoern, we've got a question here that's related to predictive analytics. So Joe McFadden asks, what could the political ramifications be, both positive and negative, for the use of AI in the future?
Political ramifications. So using predictive analytics in politics, or
I guess for kind of understanding kind of the way an election might go, or used to kind of understand kind of data afterwards, policy kind of making and all of that as well.
Okay, so the predictive analytics is already used today in today's election campaigns to predict the outcome, because when you watch the news channels, they all tell you, oh, we're predicting the outcome will be A, B, or C. So they already using predictive analytics based on a subset of data, and therefore extrapolating what that is likely to show as an end result. In other areas of politics, it's probably a bit difficult to say, but I could see how governments or even councils use predictive analytics to make decisions. Again, I mentioned planning earlier, so that could help drive an outcome to say, okay, where is planning more likely to be accepted in certain areas of the county or a city. So different areas there. I think it's an interesting topic.
I was going to say, I know in Japan that they're using kind of AI to understand where to best kind of distribute kind of budget, public sector budget, because they know where the needs are, but also where the needs shift as well across society. And I think that's kind of a really good example of how kind of public sector money can be allocated, but also kind of policy can change based on data being analysed from a citizen point of view.
Yes, absolutely. And in local government, there are also ways you can then use a machine learning model to say, okay, what happens if we change the council tax by only, I don't know, £1 for this type of housing band? You can model and work out how much more revenue it would give you, but at the same time, other housing bands for council tax, if we reduce it, that would give them a greater relief and so on. So yeah, there are different ways to use that, absolutely. Yeah. Okay. Great. No, I like the questions, and it's great to see there's so much interest there. So let me take you now to a different aspect, and I mentioned this earlier about the deep learning. So utilizing data and multi-layered information to reveal powerful, actionable insights. So I want to show you this picture here to explain how data is really used when we say we load data into a data set for machine learning. So if we start here on the very left-hand side in the picture, you see it's just a cloud of data points, and as you gather data, as you gather the data together, it's probably unstructured and not necessarily related. You have got individual records or results and pieces of information. So what we're then doing is we, of course, use, for example, in Azure, a common data platform. Let's just call it a data lake, where we can gather all this data together. So you build a compound of data. The reason why that's useful, because then you can use your machine learning algorithms to start making sense of the data, orchestrating the data and all this. The more you orchestrate and transform the data, just as a visualization, it doesn't have to be a cube, as we see here in the third picture, but a cube helps to appreciate this. So machine learning will put the data into a structure it determines itself. It's not you creating the structure. Machine learning builds a structure for itself. Let's just say the structure is a cube. So the data, structured and unstructured data, will then be arranged in this cube in rows, in layers, and of course in columns. What that means is the machine learning algorithm can then analyze the data, simplistically spoken, in columns and rows, and pinpoint individual data points through coordinates to say, that one piece of information sits somewhere there in that cube. So it's still very quick to retrieve and refer to, but the data is for machine learning in a structured format. In reality, it's not a cube. It's not a cube you remember from old data warehousing days where the data was a cube. I'm just using the cube as an example to appreciate the layering and the structuring of data. But what that also means, now that we've got the data all together and machine learning has structured and analyzed and transformed it, if we go back to the example of JFK from the beginning, I've taken here a little screenshot, and you remember this from the beginning. The data now, the data entities, which now are logical entities, can now be put together and correlated with each other, if there is indeed a correlation. So you remember with JFK, Lee Harvey Oswald is related to JFK, and JFK is related to Cuba. So we have a correlation of data entities. And all of this, of course, helps you as the end user to analyze the data and interrogate the data, but also feed more data into the cube to then use the given data in the machine learning model to understand and, for example, predict other information. So that's a way to summarize how we use the multi-layered information to then reveal the actionable insights. And the JFK was one example. Another example could be if you think of, not sure why I'm picking such a gruesome example, but think of, you have got lots of murders that seem to be unrelated and you want to find a serial killer. And maybe a year ago. So there was a multi-part TV program about one of the serial killers, and that was before the days of computers. There was a guy who said, "Oh, I remember there was a red car involved. If he wouldn't have been at the right time in the right conversation, and him remembering the red car, God knows if that serial killer would have ever been found." With something like this, with machine learning and the way I described what I've just described, finding the red car in here is absolutely dead easy, because all the data was already ingested and it's just there. And so you can make the correlation so easy, which gives you the actionable insight.
And Bjoern, I've got a question here. And it's related to kind of, I guess, big data and then actionable insights. Big organizations usually have an abundance of data, albeit somewhat unstructured.
Yeah.
To enable the use of AI, and that enables them to use AI technology. Mm-hmm. However, SMEs who could arguably benefit more from AI will have much less data. So any suggestions on how SMEs can get their hands on useful data in order to avoid them being disadvantaged as we move into the fourth industrial revolution?
So SMEs, of course, should still leverage. Let me start with the concept of the common data model. I think an organization will benefit so much from bringing all the different data silos and data sources together into a common data platform. The reason being is, with machine learning, you can detect and realize correlations that a human would never think of. So that's a great example. But also, let me take the example of public sector again with the council. If I don't know, somebody in adult social care is dealing with a patient with a case, if you had other information gathered across the public sector, it would be so much more beneficial, both for the council and for the patient, of course, to give them adequate help. For an SME, why should an SME not be able to tap into this great common data service? Because an SME can leverage the insight given for his specific use case. So again, I think both work very well together, and it's more not a why, but an of course, I would say.
I think that's really important, isn't it? It's kind of adapting and kind of utilizing sources. I think also open data as well. There's a lot of data out there that you can kind of tap into to bring in new insights into your organization, but you might not have that direct data. And even if you have a small data set, mixing it with those other data sources can give you more enlightening feedback and insights.
Absolutely. And this is again an example for the multi-layered information. So if you as a city or as a council say, okay, I want to understand my traffic to reduce emissions, you can overlay weather data, which gives you an additional level of insight. Well, if it's really bright and sunny, it's very likely there are less cars on the road anyway. But having the weather information on top makes that even clearer because of the correlation.
Absolutely.
Yeah. Okay, great. So let me show you something else. Microsoft's AI platform and how our suite of services can help you innovate and accelerate what you do. I started off on this topic, and I don't want this to be just a Microsoft sales pitch, but to really bring the technology that's the closest to you even closer with things that you probably don't realize. I started off with 10 examples and I made it 11 because, yeah, I just wanted to cram as much into this slide as possible. So in the current version of the Office products, you have got so many great examples. So in PowerPoint, we now have what's called the PowerPoint Designer, which gives you design ideas. People who are not very good with, not very creative, and I count myself into that group as well, I really benefit from this. It can go as far to even create automatically a timeline for you if you just bullet point dates or times in the slide, and then the designer says, oh, I recognize these are dates or times, and you can use a timeline automatically generated. Another aspect which I also love and use every day, every morning when Outlook or Office 365 realizes I've logged in, very soon after I receive an email with a daily briefing, summarizes what meetings do I have today, what have I committed to deliver today, and all of this uses the cognitive services, picking up the semantics that I said, oh yeah, I will reply to you by this date. So all of this will be immersed into a daily briefing email. So really useful what's there. Another example here, the third one along Power BI. Hopefully most of you know Power BI. If not, it's an application where you can create very impactful dashboards and reports with. You can use all kinds of data sources, but the amazing thing is once you have created such a report, it allows you to do what we call a natural language query. So in this picture here, you see at the top, there's a text box as part of this diagram. And you can just type a question. What's the total amount of sales for Q3 or for Contoso or whatever? And based on the information that you have, obviously as part of your data set, the machine learning can just understand what you're asking, and it presents you the right information in a graph that you haven't even put into Power BI. It just presents the data in the most meaningful way back to you. So yeah, really, really useful. The fourth example, OneNote. I'm sure lots of people have heard of OneNote. I can only recommend throw away your old paper-based notebooks, start using OneNote, because all the information that you keep writing is preserved electronically. You can search through it. You don't need to keep a stack of books and remember, oh, in which book did I write this in? So very useful. And it can do really clever things. It can, as you draw something, it can convert a drawn shape into a proper symmetrical shape for you to make it even more interesting. It can convert your handwritten text into proper machine written text. We call this ink to text, and lots of other great features. So OneNote is one of those. Probably not so much these days, but up until COVID hit us, lots of people were out on the road and commuting and traveling. So with the Outlook mobile app, Outlook for mobiles, you have a feature called Read My Emails. So you can just ask Cortana to read your emails, and you just listen to it, and just become more effective and accelerate what you do. Talking about mobile devices, we have got an app, and this is one I am most proud of all of these examples. The app is called Seeing AI, and it uses lots of things I talked about earlier. So Seeing AI is predominantly there for people who have vision impairment. Seeing AI can be put on an iPhone, for example, and you hold it up and ask the app, what do you see? And the app can, for example, say, like I gave the example earlier, oh, I see a gray with black hair and a gray jumper in front of you, and he's smiling. Or when you are in a restaurant, it can read the menu for you, and lots of other great examples. So it's really aiding people with a vision impairment. And even if you haven't got a vision impairment, for those of you around you who have that, please share that with them. The app is free to use. It's so easy to use. There are great videos out on YouTube how to use it. It's fantastic. The bottom row of examples are more for the real techies, but I don't want to discriminate anybody. These examples are worth knowing about and what functionality is out there. So the first one, within our Power Platform, in Power Apps, we have now something called the AI Builder. Also in Power Automate, you find it as well. The AI builder can do lots of things, but the one I wanted to call out the most is our forms analyzer. So think about, you've got an invoice, you can train the model to say, okay, I usually get these types of documents, and the AI builder can then extract that data and put it into structured format, into an Excel file, into a SharePoint list, or wherever you want to put the data. And of course, it's so much quicker and easier to extract data than having to open every invoice every month that you receive. Some organizations receive loads of invoices. So again, you can, if you only save 1 minute for each invoice that you receive, that's a lot of time saved. We just added more functionality there. You can now also automatically ingest information from receipts for your expenses. All of that can be automated, so that's brilliant. And the second example here I want to give from this bottom row is our Q&A bot maker. You can create a bot in probably 30 minutes, won't take you much longer. And it could be something very small for your line of work or what's important to you to say, let's say I work with a lot of suppliers. Who are my contacts in the supplier? You can just create a 2-column list in Excel, write them all down, create a bot, and then you just ask the bot, who's the contact for supplier X, and the bot will respond. Can respond into Teams or just in a bot itself on a web page. So lots of things you can do with the Q&A maker. You can give different variations. You can build a knowledge base that can be answered from. The examples are endless, really. The Power Virtual Agent is a bit more workflow driven, but it's a bot. Think about the insurance example I gave earlier, or think about you want to request a new bin from your council. The council will ask you what's your postcode, and then in the next stage it will ask you confirm the street, and then what bin do you want and need? Do you need a blue or green bin? And then maybe it asks you, do you want something else? And then you could loop back. So this kind of workflow scenario is something you can build with our Power Virtual Agent, and you can hook into other components as well. So yeah, very, very intuitive and low code. And as you see in this little picture, if that's big enough for you, it's all GUI driven, so it's all visual. You don't have to code anything, or not much at all. And the last two are hanging very close together. So cognitive services is our summary, and you heard me talking about this throughout the session. So cognitive services is really the combination of everything that we have in AI capabilities. The speech to text, text to speech, object detection, so any visual functionalities that we have, our bot technologies. So all of our cognitive services, there's a whole raft of services that we have. I can only encourage you to look at them, and they are all very easy to implement and to utilize. So great collection there. And the last one is our bot framework. So like the Q&A maker, you can build a bot, but with the bot framework, it can be far more complex. And yeah, really, you can build a bot to your very own specific needs. So that's just to round up the Microsoft AI platform. And I think we are almost at time. Hopefully, we've got time for a couple more questions here, Yannis.
We have indeed. We have indeed. So I think the first one comes from Leanne, and she wants to know how do you get into AI? Kind of what are some of the learning resources out there to kind of start from scratch and build up your competencies?
Yeah, great question. So we have on the Microsoft Learn website learning paths, and it's all free content, bite-sized chunks to really get you started. For the cognitive service, so if you want to build a bot, you can sign up for free on the Azure website and create your very own Azure environment. The Q&A maker, you don't need to write any code, it does it all for you. And when you sign up for an Azure trial, you get free money in Azure to spend for a short while. So that's a very easy way to get into this. Look up, I suppose, things that really interest you. I would start with the cognitive services to really understand what's out there. Bots is easy as well, but things like the JFK example is a very much end-to-end thing you could rebuild. But start with the cognitive services. Explore what you can do with the cognitive services. We have got online ways to demonstrate this. So, for example, you could drag a picture of Albert Einstein into the cognitive services website for us, and it tells you, oh, this is Albert Einstein or other famous people. So it really, to demonstrate, there's quite an impact when you experience this firsthand.
Yeah, absolutely. And I think to add to that, just phenomenal what kind of Microsoft are doing across the West Midlands alongside some other partners at the Digital Skills Partnership, obviously headed up by kind of the great Lee Jones there. And, Microsoft have obviously made a commitment as well by 2021, they're going to help 1.5 million people in the UK build careers in technology. By 2025. So yeah, big commitment there from Microsoft. So thank you for that commitment. And finally, final question: what excites you most about AI?
I'm still blown away with the capabilities that we already have in this field, and how much more there is to come. And then looking at the practical examples that I gave you earlier, for example, the health example, where you see we can really make a difference. We can change health outcomes for illnesses, and we can, there's so many areas we can really drastically transform how businesses work and operate. If you think all the documents you can ingest and extract data from this, if we all would do this, we can improve the way of working and living so much. And then all of this improvement has an outcome to us as the citizens, and we can really make an impact here and a difference.
100%, absolutely, and that's unfortunately all the time we've got, and that brings to a close Birmingham Tech Week 2020. Well, from a keynote point of view, anyway, we have got our closing event coming up at 4:30, so there's a chance for everyone to don their glad rags or turn up how you want, really. Have a glass of wine or a beer or whatever takes your fancy in hand. And come and let us celebrate the kind of end of Birmingham Tech Week 2020. And we've got a special message as well from the Minister for Digital and Culture at the start of that closing event. So Bjoern, all that's left for me to say is thank you. I know we've got a lot of love in the chat as well. A lot of people kind of saying how great this has been. We haven't had a chance to answer all the questions. So Bjoern, if it's okay with you, I'm going to save the chat and then actually kind of send you some of the specific questions so you can kind of answer those, and we'll work together on that. Maybe
yes, that would be great. Yeah, thank you very much for having me, and what a fantastic session, fantastic week it has been, and thanks very much for the great participation from the audience. Thank you very much.
Our pleasure. Thank you. Have a great weekend, everyone. And Bjoern, speak to you soon. Bye-bye.
Thank you very much. Bye-bye.